Welcome. This is Joti Balani. I am founder and managing director of FreshRiver.ai. We are a conversational AI consultancy focused on strategy and delivery of conversational AI services for the Fortune 100. And I'm joined today by John Hughes, who is the accuracy team lead from Speechmatics. Welcome, John.
Thank you very much. Happy to be here.
It's amazing. Are you enjoying the show so far?
Yeah, it's good. It's great. I'm having some really good conversations with everyone, actually, and learning a lot about conversational AI, how that works, and some of the challenges as well. So yeah, enjoying it so far.
It's excellent. So what are you guys targeting in the types of problems that you're solving in conversational AI? Tell us a little bit about that.
Yeah, so at Speechmatics, what the service we provide is speech to text. And that's what we're very laser focused on. We provide the APIs for other businesses to come and use and plug that software in. So we sell to other businesses there. So for example, in conversational AI, a big part of that is you need to understand what someone has said before you can then kind of go on to the next question to ask them, before putting them through to an agent if they need to,
right,
or solving the problems which they're facing. So a key part of that is being, very accurate in understanding what you're saying. And the key challenges that we face is, we really need to understand every single voice. We don't want there to be a digital divide if someone has a speech impediment or
right,
a strong accent, or that language they're speaking in isn't their first. So those are the types of challenges that we face with the speech-to-text technology there.
So that's interesting, because I'd recently done a project, our team and I think it was 2020, for a very large retailer. What I found fascinating was the range of accents, non-native English speakers, or even native English speakers that have ranges of, say, twangs, right? How does that work? I mean, even in the UK, there's ranges of dialects, right?
Huge range, yeah, of course. And, it's different for every single person, based on their upbringing, where they might have lived, or even, the slang which they use can be very, very different, right?
Yeah.
And it's a difficult problem to solve like that. And, conventional ASR, there's been kind of lots of maybe handcrafted features that people look like, the tone of people's voices, and you can kind of add that into the feature vectors which you feed into the models. But actually, what we're trying to do at Speechmatics is learn from the data directly, and actually learn from a lot of the data which doesn't have labels. And by that I mean, in conventional speech recognition, you train something called an acoustic model. And you do that in a completely supervised way. So you've got to have your audio, someone speaking, and someone needs to have typed up the transcript of what that person has said. And then what you're trying to do is you're trying to maximize the probability of the words that they've spoken and minimize the probability of everything else.
Right.
So that's supervised learning. But what we're trying to do, and what we are doing, we released at the end of last year, is we're using self-supervised learning to power our enhanced models. And that means that we can utilize all of the unlabeled audio that's out there, which is in a huge abundance, basically. So we're currently using 1 million hours of audio, and English systems, it's on the order of 10,000 to 100,000 hours.
Wow.
So it's like a hell of a lot more audio that we're using. It means there's loads more accents in there. And this is over all languages as well. So this self-supervised learning model understands speech in all languages. And then
where are you grabbing all of this? Because, the accuracy of the model is dictated by how much training it gets, right? Where are you grabbing it from, like from public sources?
Yeah, there's lots of public sources. There's a huge amount of data you can get freely available.
Okay.
So we're using a lot of that. We also work with some of our customers as well, and they can provide us with lots of audio.
Got it.
So those are the main two. You can scrape a lot as well.
So given you are leading the team on accuracy,
that's right?
Yeah. Word error rate, I think, is a metric that you're very carefully measuring to define the success, because it can't be 100%, but it gets darn close. Tell us a little about what is the word error rate metric in your view?
So word error rate is simply, you can count up the number of errors that your system makes, and then you can divide that through by the number of words which you have in the reference transcript. So the one that's been typed up by someone, that's the ground truth. And then if there are no errors at all, your word error rate is 0, which means you're nailing it, you're completely perfect. So all the research decisions we make we want to be making sure that word error rate is driving towards zero. But the big problem with this actually is a lot of the times the gold standard transcripts which people use, there are lots of mistakes in there because it's quite a difficult thing to do. If you're transcribing an interview or something, you have to type it down very quickly, or you might not understand yourself. Like, humans aren't perfect at doing this.
That's right.
So there can be lots of problems there. And also, especially with things like dates or currencies or lots of other things, there's actually multiple ways you can say the same thing.
Correct.
So, or write the same thing. So you can say a date like October 1st, 2022.
Right.
But you can write that in loads of different ways, right?
That's right.
And if you have the wrong one in your reference transcript and you try and score against that, you're going to get really heavily penalized.
Right.
Even though your speech recognition system might have been completely accurate.
Yeah.
Just in a different form. So we're working on kind of a new novel way of doing of scoring transcripts that harnesses the power of large language models, because large language models, they're trained on basically all of the text on the internet.
Correct.
And they understand the nuances and the differences in how you write things, and they can say, that's not a problem at all. So I'm going to say that error is nothing, or that's a minor error. But if you omit the word suspected before murderer, and it's in like a court case or something, and you're looking at the transcript after, that's a serious problem because it causes misinformation.
Right.
So you want to tag that as a really serious error. You want to weight that much higher, because what error rate is going to do that? It's going to weight that omission of suspected before murderer the same as changing in and an, for example, in a sentence which you just be able to read through, you'd be able to understand what's going on.
Right.
So that's what we're working on, and I'm giving a talk later as well on how that works.
I think that's brilliant, because I think what you're touching upon, there's domain sensitivity. So it's not like it's a one-size-fits-all where you train this, right? Because, for example, healthcare, you want to be very careful about how you're weighting words, like, for example, the names of drugs or diseases, right?
And those are the keywords you'd want to get right.
That's right.
Because it's so important, especially for downstream tasks like here with conversational AI, a lot of the natural language understanding, which is built on top of the transcripts, if you're getting those keywords wrong, they can't find them.
That's right.
They can't do anything they want to do. So that's why we're looking for metrics to measure things slightly differently.
So do you depend on the client to give you those domain-specific language to train on top of, when you're doing open source data, it's more about how humans speak. But for the domain word, you rely on the client to sort of bring it in, or you're doing other corpus.
Do you mean to bring in extra data?
Yeah, the domain-specific training.
We have some partners, that we can do that. But also, we have other functionality like custom dictionary, where say you're talking about specific drugs that might not be directly in our vocabulary, you can put those in and then we'll be very good at transcribing them still. So we have like added functionality, and we can also now say, again, it's healthcare. Say there's a load of transcripts from doctors having conversations with their clients, or other maybe textbook information. You can bias our models to that text so it will perform better. But so those are ways we can make those applications better, and we can collect data from our customers if we have partnerships. But I think the main way we actually get our gains is through self-supervised learning that I was explaining earlier.
Yep.
We really get a massive bump in performance. Like, imagine you have you essentially get rid of a third of errors that you had before. So if you've got 30 errors there, you get rid of 10.
I see. What about GDPR? So when you collect speech to convert to text, right, there's sensitivity around people's names and addresses and stuff. Are you guys making that as a normal part so you're compliant all the time?
So with that, we provide ways to run our systems on premise. So if people have GDPR concerns or very private data, they can run everything locally. And it means they don't have to send it up to our cloud or they don't have to. The data doesn't have to leave, their premises, right? So that's kind of key.
So those are interesting decisions, right? In fact, all the platforms, on the show, at the show here, those decisions are very critical because a lot of these companies are very worried about their data leaving their premises, right? So there's on-prem, or there's public cloud, or there's hybrid cloud. I'm sure you guys have every flavor of it, right? So they can make that decision. Is that pretty much accurate?
Yeah.
That's excellent.
Exactly.
Finally, so you earned the Queen's Award in 2019 as
That's right, we did, yeah.
the top technology innovators. I think that was brilliant. You also have actually compared and benchmarked yourself against the competitors because there's a lot of competition out there, right?
Yeah.
You guys are actually stack ranked right at the top. How
Yeah,
did you
right
do that?
at the top. Yeah. So we're the most accurate and inclusive speech recognition on the market right now. And again, that's all down to the innovations which we've done with self-supervised learning. We're laser focused on understanding every voice. And that's really, really where we stand out in noisy environments, people with strong accents, and also across all the different domains for finance and healthcare.
Are there any languages you don't do just yet? Because there are just so many globally and dialects.
Yeah, sure. I mean, that's another key part of understanding every voice. Is we've got to have good coverage of languages. So we have 48 languages now. We've just released 14 new as of last quarter.
Okay.
Wow. And so we've something which I've been heavily involved with is really streamlining our machine learning pipelines, and getting the data ingestion very seamless, running through new languages very quickly. So now, we'll be able to train new languages very, very quickly and keep on expanding our horizons there as well.
That's amazing.
But yes, that's definitely a key part, and we have
that's
good
the
coverage.
Growth, right? You guys are looking for. So, if you're able to reveal, what's the next 6 to 12 months horizon? Any interesting things we should keep an eye on that's going to be coming out?
Well, I mean, we're looking to completely kind of dominate on the different operating point front. So we want to have multiple models, some that are very quick, that give decent accuracy, and then we want to have also like a completely flagship operating point that still beats everyone on the market, and all of these are going to be running hopefully very seamlessly on the GPU too. So they'll be very quick. We're going to improve our.
I see. So like a light
throughput
version. Before they get in, because I think that's a function of how much compute and storage you'll be using. Is that how you've decided that you need to have a distinction?
The throughput's better on the GPU because you can parallelize how many kind of utterances and audio streams that you're putting in at once. So GPUs are more expensive to run, but they can do lots in parallel.
All right.
So running them on GPU is great for throughput.
Gotcha. So this is your reach, right? Trying to get to more users, right, and companies that are able to adopt it.
Yeah, and we want to keep our premium brand, so we're doing everything we can to keep that accuracy across all our languages best in class.
Well, that's fantastic, John. I think you guys are doing incredible work. Can't wait to see what's coming out next. Thank you for joining us.
Yeah, thank you very much.
All right, take care. Enjoy the rest of the show.
Cheers.